Hi, I'm Bob. Welcome back to the 5 Minute Econometrics, an econometric tutorial on econometric concepts and estimation methods. Today, we will have a look at the concepts endogeneity and exogeneity. They closely relate to the fourth assumption of the classical linear models, the zero conditional mean assumption. If the assumption fails, or equivalently, if the explanatory variable x is correlated with the error term epsilon, then the explanatory variable is endogenous. The model suffers from an endogeneity problem. If the explanatory variable x is not correlated with the error term epsilon, then x is said to be an exogenous explanatory variable. Endogenous explanatory variables lead to biased OLS estimates. The OLS estimators beta hats are not unbiased or consistent estimator of the population parameter beta. As a result, we don't know whether there is a ceteris paribus relationship between the explanatory variable x and the outcome variable y. There are reasons why endogeneity occurs. First, some relevant factors are omitted from the model. Omitted variable bias is the direct and leading cause of endogeneity. The second reason is reverse causality. Suppose we are interested in the causal effect of alcohol abuse on the probability of being unemployed. We regress the employment status on the alcohol abuse measure and find a significant coefficient estimate. However, we suspect that unemployed people are more likely to be addicted to alcohol than employed people. If this is the case, the estimate we get combines the two simultaneous effects. We have to figure out how to separate the causal effect we are interested in, the alcohol abuse effect on unemployment, from the reverse causal effect we are not interested in, the unemployment effect on alcohol abuse. In addition to this example, simultaneous causality occurs when the data we observed and collected result from two forces interacting simultaneously, such as the data on work hours and wages. The data reflect the labor market equilibrium. It represents the outcome of the interplay of labor supply and demand. The fourth source of endogeneity is sample selection. It happens when the sample we use cannot represent the population we are interested in. A well-known example is the study of married women's labor supply behavior. The sample we used in the model is for married women with positive work hours and earnings. The women who stayed at home were excluded from the model. It can be seen as a particular case of omitted variable bias because the decision to work or self-selection into the labor force is an omitted factor we should consider. Alleviating the endogeneity problem is usually the priority in our research. There were four major methods we often use to solve the endogeneity problem. The most popular approach is the instrumental variables estimation method. Since endogeneity is caused by the correlation between the explanatory variable of interest, x, and the error term epsilon, we can find another variable, z, that is not correlated with the error term. We replace x with the projection of x on z. The estimate is consistent because the projection is no longer correlated with the error term. The requirements and the procedures for using the IV method can be found in the link below. That video also introduces other methods to mitigate the endogeneity problem, panel data fixed effects methods, difference in differences approach, and sample selection bias corrections. Thank you so much for watching this video. See you soon on the next topic. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.